Chapter 4: The Absolute Chronology of the Neo-Babylonian Era. As explained earlier in Chapter 2, an absolute chronology is usually best established by the aid of ancient astronomical observations. Although no observations usable for dating purposes are recorded in the Bible, it was pointed out that at 2 Kings 25, 2 and 8, the dating of the desolation of Jerusalem to the 11th year of King Zedekiah, the last king of Judah, is synchronized with the 19th year of King Nebuchadnezzar, the Babylonian desolator of the city. If the reign of Nebuchadnezzar could be fixed astronomically to our era, it would be possible to establish the BCE date for the desolation of Jerusalem. In this chapter, it will be demonstrated that the whole Neo-Babylonian period, including the reign of Nebuchadnezzar, may be established as an absolute chronology by the aid of astronomical cuneiform documents found in Mesopotamia. Subheading: The study of the Babylonian astronomical documents. The study of the astronomical cuneiform texts started more than 100 years ago. One of the leading Assyriologists at that time was J.N. Strassmeyer, living from 1846 to 1920. He was a diligent copyist of the cuneiform texts that from the 1870s onwards were being brought from Mesopotamia to the British Museum in enormous quantities. Strassmeyer found that a great number of the texts contained astronomical data. He sent copies of these texts to his colleague J. Epping, who taught mathematics and astronomy in Falkenberg, Holland. Thus, Epping, who lived from 1835 to 1894, was to become the pioneer in the study of the Babylonian astronomical texts. After his death, another of Strassmeyer's colleagues, Franz Xaver Kugler, who lived from 1862 to 1929, took over the work of Epping. Few, if any, have contributed as much to the study of the astronomical texts as Kugler. He published his results in a series of monumental works, such as Die Babylonische Mondrenschung in 1901, Sternkunde and Sterngeist in Babel, volumes 1 and 2, in 1907 to 1924, and Von Moses bis Paulus in 1922. The last two works include detailed studies of ancient chronology, in which the astronomical texts are fully developed and studied in depth. After Kugler's death in 1929, some of the key names in the study of the Babylonian astronomy have been P.J. Schaumburger, deceased in 1955, Otto Neubauer from 1899 to 1990, and Abraham J. Sachs from 1914 to 1983. Many other modern scholars have contributed much to the understanding of the astronomical texts, some of whom have been consulted for the following discussion. Subheading: Ancient Astronomy. As can be deduced from the Babylonian astronomical tablets, a regular and systematic study of the sky began in the mid-8th century BCE, perhaps even earlier. Trained observers were specifically employed to carry out a regular watch of the positions and movements of the sun, the moon, and the planets, and to record from day to day the phenomena observed. This regular activity was performed at a number of observational sites in Mesopotamia, located in the cities of Babylon, Uruk, Nippur, Sippar, Borsippa, Kutha, and Dilbat. As a result of this activity, the Babylonian scholars at an early stage had recognized the various cycles of the sun, the moon, and the 5 planets visible to the naked eye: Mercury, Venus, Mars, Jupiter, and Saturn, enabling them even to predict certain phenomena, such as lunar eclipses. Finally, in the Persian and Seleucid eras, they developed a very high level of scientific and mathematical astronomy that had never been reached by any other ancient civilization. Subheading: The nature of the Babylonian astronomical texts. Although astronomical cuneiform texts have been found also in the ruins of Nineveh and Uruk, the bulk of the texts, about 1,600, comes from an astronomical archive somewhere in the city of Babylon. The archive was found and emptied by local inhabitants from nearby villages, and the exact finding spot within the city is not known today. Most of the texts were obtained for the British Museum from dealers in the latter part of the 19th century. About 300 of the texts are concerned with scientific mathematical astronomy and belong to the last 4 centuries BCE. Most of them are ephemerides, that is, tables with calculations of the positions of the moon and the 5 naked eye planets. The greater part of the remaining texts, however, about 1,300 in number, are non-mathematical and principally observational in nature. The observations date from about 750 BCE to the 1st century of the Christian era. The great number of observational texts are of the utmost importance for establishing the absolute chronology of this whole period. With respect to content, the non-mathematical texts may be subdivided into various categories. By far the largest group are the so-called astronomical diaries. These record on a regular basis a large number of phenomena, including the positions of the moon and the planets. It is generally accepted that such diaries were kept continuously from the mid-8th century BCE onwards. The other categories of texts, which include almanacs, each recording astronomical data for one particular Babylonian year, texts with planetary observations, each giving data for one specific planet, and texts recording lunar eclipses, were apparently excerpts from the diaries. Thus, although only a handful of diaries from the 4 earliest centuries are extant, quite a number of the observations recorded in the other diaries, compiled in this early period, have been preserved in these excerpts. A comprehensive examination of all the non-mathematical texts was started several decades ago by Dr. A.J. Sachs, who devoted the last 30 years of his life to the study of these texts. After his death in 1983, Sachs' work has been continued by Professor Hermann Hunger in Vienna, Austria, who today is the leading expert on the astronomical observational texts. Both of these authorities were consulted for the following discussion. Subheading A. The Astronomical Diaries. A diary usually covers the 6 or 7 months of the first or second half of a particular Babylonian year and records, often on a day-to-day basis, the positions of the moon and the planets in relation to certain stars and constellations, and also gives details of lunar and solar eclipses. Much additional information is added, such as meteorological events, earthquakes, market prices, and similar data. Sometimes also historical events are recorded. Over 2,000 years old, it is only to be expected that these clay tablets are often fragmentary. More than 1,200 fragments of astronomical diaries of various sizes have been discovered, but because of their fragmentary condition, only about a third of the number are datable. Most of these cover the period from 385 to 61 BCE, and contain astronomical information from about 180 of these years, thus firmly establishing the chronology of this period. Half a dozen of the diaries are earlier. The 2 oldest are VAT 4956 from the 6th and BM 32312 from the 7th centuries BCE. Both provide absolute dates that firmly establish the length of the Neo-Babylonian period. Subheading A1, the Astronomical Diary VAT or VAT 4956. The most important astronomical diary for our discussion is designated VAT 4956 and is kept in the Near Eastern Department in the Berlin Museum. This diary is dated from Nisanu I of Nebuchadnezzar's 37th regnal year to Nisanu I of his 38th regnal year, recording observations from 5 months of his 37th year, months 1, 2, 3, 11, and 12. The most recent transcription and translation of the text is that of Sachs and Hunger, published in 1988. Among the many observed positions recorded on VAT 4956, there are about 30 which are so exactly described that modern astronomers can easily fix the precise dates when they were seen. By doing so, they've been able to show that all these observations of the moon and the 5 then known planets must have been made during the year 568-67 BCE. If Nebuchadnezzar's 37th regnal year was 568-67 BCE, then it follows that his first year must have been 604-03 BCE, and his 18th year, during which he desolated Jerusalem, 587-86 BCE. This is the same date indicated by all the 7 lines of evidence discussed in the previous chapter. Could all these observations also have been made 20 years earlier, in the year 588-87 BCE, which, according to the Chronology of the Watchtower Society's Bible Dictionary, Insight on the Scriptures, corresponded to Nebuchadnezzar's 37th regnal year? The same dictionary acknowledges that modern chronologers point out that such a combination of astronomical positions would not be duplicated again in thousands of years. Let us consider one example. According to this diary, on Nisanu I of Nebuchadnezzar's 37th year, the planet Saturn could be observed, quote, in front of the swallow. The swallow referring to the southwest part of the constellation of the fishes of the zodiac, or Pisces. As Saturn has a revolution of circa 29.5 years, it moves through the whole zodiac in 29.5 years. This means that it can be observed in each of the 12 constellations of the zodiac for about 2.5 years on the average. It means also that Saturn could be seen, quote, in front of the swallow 29.5 years previous to 568-67 BCE, that is in 597 or 96 BCE, but certainly not 20 years earlier, in 588-87, the date the Watchtower would like to assign for Nebuchadnezzar's 37th regnal year. That is simply an astronomical impossibility. Even in the case of this one planet, but there are 5 planets that figure in the diary's astronomical observations. Add, therefore, the different revolutions of the other 4 planets, the positions of which are specified several times in the text, along with the positions given for the moon at various times of the year, and it becomes easily understood why such a combination of observations could not be made again in thousands of years. The observations recorded in VAT 4956 must have been made in the year 568-67 BCE because they fit no other situation which occurred either thousands of years before or after that date. Thus, VAT 4956 gives very strong support to the chronology of the Neo-Babylonian era as established by the historians. Attempting to overcome this evidence, the Watchtower Society, in the above-mentioned Bible Dictionary, goes on to state that, quote, while to some this might seem like incontrovertible evidence, there are factors greatly reducing its strength, end quote. What are these factors? And do they genuinely reduce the strength of the evidence in the ancient tablet? A. Quote, the first is that the observations made in Babylon may have contained errors. The Babylonian astronomers showed greatest concern for celestial events or phenomena occurring close to the horizon at the rising or setting of the moon or the sun. However, the horizon, as viewed from Babylon, is frequently obscured by sandstorms. End quote. Then Professor Otto Neubauer is quoted as saying that Ptolemy complained about, quote, the lack of reliable planetary observations from ancient Babylon, end quote. However, many of the observations recorded in the diaries were not made close to the horizon, but higher up in the sky. Further, Babylonian astronomers had several means of overcoming unfavorable weather conditions. As noted earlier, the observations were performed at a number of sites in Mesopotamia. What could not be observed at one place due to clouds or sandstorms could probably be observed somewhere else. One method used to get over the difficulty of observing stars close to the horizon due to dust was to observe instead the, quote, simultaneously occurring of other stars, the so-called Zikpu stars, end quote. That is, stars crossing the meridian higher up on the sky at their culmination. Finally, the horizon as viewed from Babylon was not obscured by sandstorms every day, and some planetary events could be observed many days or weeks in succession. Also higher up in the sky, for example, the position of Saturn, which according to our text could be observed, quote, in front of the swallow, the southwest part of the fishes. As was pointed out above, Saturn can be observed in each of the 12 constellations of the zodiac for about 2.5 years on the average. Saturn's position in the vicinity of the southern fish, then, could have been observed for several months in succession, which would have made it impossible for Babylonian astronomers in their regular observations of the planets to make any mistake as to where this planet could be seen during the 37th year of Nebuchadnezzar, in spite of frequent sandstorms. Our text, in fact, directly states that Saturn was observed in front of the swallow, not on the first day of Nisanu, the first month, but also on the first day of Ayaru, the second month. That the observations recorded in VAT 4956 are substantially correct may be seen from the fact that all of them, except for one or two containing scribal errors, fit the same year. This would not have been the case if the observations were erroneous. The next factor brought up in the Watchtower Society's Bible Dictionary that is held to reduce the strength of VAT 4956 is the fact that some diaries are not original documents, but later copies. Quote B. Second, the fact is that the great majority of the astronomical diaries found were written not in the time of the Neo-Babylonian or Persian empires, but in the Seleucid period, from 312 to 65 BCE, although they contain data relating to those earlier periods. Historians assume that they are copies of earlier documents. End quote. There is nothing to show that most diaries are later copies, but some are, as indicated by writing conventions used in the texts. The earliest dated diaries frequently reflect the struggle of the copyists to understand the ancient documents they were copying, some of which were broken or otherwise damaged, and often the documents used an archaic terminology which the copyists tried to modernize. This is clearly true of VAT 4956 too. Twice in the text, the copyist added the comment, "broken off," indicating he was unable to decipher a word in the copy. Also, the text reflects his attempt to change the archaic terminology. But did he also change the content of the text? On this, the first translators of the text, P.V. Neugebauer and E.F. Widener, concluded, quote, "As far as the contents are concerned, the copy is of course a faithful reproduction of the original," end quote. Other scholars who since have examined the document agree. Professor Peter Huber states, quote, "It is preserved only in a copy of much later date, but what appears to be a faithful transcript, orthographically somewhat modernized, of an original Nebuchadnezzar's time," end quote. Suppose that some of the material in the about 30 completely received observations recorded in VAT 4956 had been distorted by later copyists. How great is the possibility that all these distorted observations would fit into one and the same year, the very one corroborated by Berossus, the royal canon, the chronicles, the royal inscriptions, the contract tablets, the Uruk king list, and many other documents, that is, Nebuchadnezzar's 37th regnal year. Accidental errors of this kind do not cooperate to such a great extent, so there is no sound reason to doubt that the original observations have been correctly preserved in our copy. Quote C. Finally, as in the case of Ptolemy, even though the astronomical information, as now interpreted and understood, on the text discovered is basically accurate, this does not prove that the historical information accompanying it is accurate. Even as Ptolemy used the reigns of ancient kings, as he understood them, simply as a framework in which to place his astronomical data, so too the writers or copyists of the astronomical texts of the Seleucid period may have simply inserted in their astronomical texts what was then the accepted or popular chronology of that time. End quote. What is suggested by the Watchtower organization is that the later copyists changed the dates found in the diaries in order to adapt them to their own concept of the ancient Babylonian and Persian chronology. Thus, a writer in the Awake magazine imagines that the copyists of VAT 4956 may, in line with the chronology accepted in his time, have inserted the 37th year of Nebuchadnezzar. Is this a plausible theory? As was pointed out above, VAT 4956 is dated from Nisanu I of Nebuchadnezzar's 37th year to Nisanu I of his 38th year. Further, almost all events mentioned in the text are dated with the month, the day, and, when necessary, the time of the day given. About 40 dates of this kind are given in the text. Though the year, of course, is not repeated at all these places, all known diaries are dated in a similar way. In order to change the years in the text, the copyist would also have been forced to change the name of the reigning king. Why? Nebuchadnezzar died in his 43rd year of rule. If his 37th year fell in 588, or 87 BCE, as the Watchtower Society holds, he must have been dead for many years by 568-67 BCE, when the observations of VAT 4956 were made. Is it really likely that the Seleucid copyists devoted themselves to such large-scale forgeries? What do we know about the popular chronology of their time, which is proposed in the Watchtower's publication as the motive for this deliberate fraud? The chronology for the Neo-Babylonian era, composed by Berossus earlier in the Seleucid period, evidently represents the contemporary or popular concept of Neo-Babylonian chronology. If counted backwards from the fall of Babylon in 539 BCE, Berossus' figures for the reigns of Neo-Babylonian kings place Nebuchadnezzar's 37th year in 568-67 BCE, as does VAT 4956. More importantly, Berossus' Neo-Babylonian chronology, as shown earlier in Chapter 3, is of the same length as that given by the many documents contemporary with the Neo-Babylonian era itself, such as chronicles, royal inscriptions, business documents, as well as with contemporary Egyptian documents. The popular Neo-Babylonian chronology, as presented in the Seleucid era then, was not something based on mere supposition, but meets the qualifications of a true and correct chronology, and there was no need for copyists to alter the ancient documents in order to adapt them to it. The theory that they falsified these documents, therefore, is groundless. Besides, it is refuted completely by other astronomical texts, including the next diary to be discussed. Subheading A2, the Astronomical Diary BM 32312. In an article published in 1974, Professor Abraham J. Sachs gives a brief presentation of the astronomical diaries. Mentioning that the oldest datable diary contains observations from the year 652 BCE, he explains how he was able to fix its date. Quote, "When I first tried to date this text, I found the astronomical content to be just barely adequate to make this date virtually certain. It was a great relief when I was able to confirm the date by matching up a historical remark in the diary with the corresponding statement for negative 651 in a well-dated historical chronicle." End quote. As this diary seemed to be of great importance for the question of Babylonian chronology, I wrote to Professor Sachs back in 1980 and asked two questions. 1. What information in the diary makes the date 651 or 652 BCE virtually certain? 2. What kind of historical remark in the diary corresponds with what statement in which well-dated chronicle? In his answer, Professor Sachs enclosed a copy of a photograph of the diary in question, BM 32312, and added information which fully answered my two questions. The astronomical contents of the diary clearly established the year as 652-51 BCE, when the observations were made. Sachs writes that the preserved astronomical events, Mercury's last visibility in the east behind Pisces, Saturn's last visibility behind Pisces, both around the 14th of the month, the first month, Mars' stationary point in Scorpio in the 17th of the month, of the first month, Mercury's first visibility in Pisces on the 6th day of month 12, uniquely determine the date. End quote. Interestingly, it cannot be claimed that this diary was redated by later copyists because the name of the king, his regnal year, and month names are broken away. Yet these data may justifiably be supplied because of a historical remark at the end of the diary. For the 27th of the month, the month name is broken away, the diary states that at the site of Hiritu in the province of Sippar, the troops of Babylonia and of Assyria fought with each other, and the troops of Babylonia withdrew and were heavily defeated. End quote. Fortunately, it is possible to place the time of this battle since it is also mentioned in a well-known Babylonian chronicle. The chronicle is the so-called Akitu Chronicle, or BM 86379, which covers a part of Shamash-Shumukin's reign, especially his last 5 years, the 16th to the 20th. The battle at Hiritu is dated in his 16th year as follows, quote, "The 16th year of Shamash-Shumukin, on the 27th day of Adar, the 12th month, the armies of Assyria and Akkad, or Babylonia, did battle in Hirit. The army of Akkad retreated from the battlefield, and a major defeat was inflicted upon them." End quote. The astronomical events described in the diary fix the battle of Hiritu on Adam 27 to 651 BCE. The Akitu Chronicle shows that this battle at this place on this day was fought in the 16th year of Shamash Umuken. Thus, Shamash Umuken's 16th year was 652 to 51 BCE. His entire reign of 22 years then may be dated to 667-66 to 648-47 BCE. Now, this is the way historians have dated Shamash Umuken's reign for a long time, and that is why Professor Sachs concluded his letter by saying, quote, "I should perhaps add that the absolute chronology of the regnal years of Shamash Shumuken was never in doubt, and it is only confirmed again by the astronomical diary." End quote. Shamash Shumuken's reign has been known, for example, through the royal canon, which gives him 20 years, and his successor, Kandalanu, 22 years. Thereafter, Nabopolassar, Nebuchadnezzar's father, succeeded to the throne. These figures are in good agreement with the ancient cuneiform sources. Business documents, as well as the Akitu Chronicle, show that Shamash Shumuken ruled for 20 years. Business documents, supported by the Uruk king list, also show that from the first year of Kandalanu to the first year of Nabopolassar was a period of 22 years. Thus, the chronology of that era supplied by these sources is as follows. Shamash Shumuken reigned 20 years from 667 to 648 BCE. Kandalanu reigned 22 years from 647 to 626 BCE. Nabopolassar for 21 years from 625 to 605 BCE. And Nebuchadnezzar for 43 years from 604 to 562. The diary BM 32312, although establishing a date prior to the Neo-Babylonian period, which began with Nabopolassar, again coincides with and helps corroborate the chronology of that era. This diary then adds yet another witness to the increasing amount of evidence against the 607 BCE date. A change of Nebuchadnezzar's 18th year from 587 to 607 BCE would also change Shamash Shumuken's 16th year from 652 to 672, but the diary BM 32312 rules out such a change. And as already pointed out, no one can claim that later copyists inserted the 16th year of Shamash Shumuken in this diary because the text is damaged, and this point and that datum is broken away. It is the unique historical information in the text, information repeated in the Akitu Chronicle, that fixes the diary to Shamash Shumuken's 16th year. This diary, therefore, may be regarded as an independent witness, which upholds the authenticity of the dates given in VAT 4956 and other diaries. Subheading B, the Saturn tablets, or BM 76738 and BM 76813. One of the most important astronomical texts from the 7th century BCE is the Saturn tablet, from the reign of the Babylonian king Kandalanu, from 647 to 26. Predecessor of Nabopolassar, Nebuchadnezzar's father. This text consists of two broken pieces, BM 76738 and BM 76813. The text was first described by C.B.F. Walker in 1983 in the Bulletin of the Society for Mesopotamian Studies. A transcription and a translation with a full discussion of the text by Mr. C.B.F. Walker has recently been published. As explained earlier, in section A1 above, the planet Saturn has a revolution of circa 29.5 years. Due to the revolution of the Earth around the Sun, Saturn disappears behind the Sun for a few weeks and reappears again at regular intervals of 378 days. The Saturn tablet gives the dates, the regnal year, month, and day in the Babylonian calendar, and the positions of the planet Saturn at its first and last appearances for a period of 14 successive years, specifically the first 14 years of Kandalanu, from 647 to 34 BCE. The name of the king, given only in the first line, is partially damaged, but may be restored as Kand-Alanu. The name of the planet is nowhere mentioned in the text, but the observations fit Saturn and no other planet. As Mr. Walker explains, quote, "The name of the planet Saturn is not given on the tablet, and the name of Kandalanu is to be restored from only a few traces in the first line. It is, however, certain that we are dealing with Saturn and Kandalanu. Saturn is the slowest moving of the visible planets, and only Saturn would move the distances indicated between successive first visibilities." End quote. The text is damaged in several places, and many of the year numbers are illegible. Years 2, 3, 6, 7, 8, and 13 are undamaged, however. Besides this, each year is covered by 2 lines in the text, one for the last appearance of the planet and the other for its first, the total number of lines covering the 14 years therefore being 28. With this framework, there's no problem in restoring the year numbers that are damaged. Most of the positions given for Saturn at its first or last appearance are legible. The entry for year 8, which is almost wholly preserved, is quoted here as an example. Quote, "Year 8, month 6, day 5, behind the furrow," or the constellation Virginis, last appearance. Year 8, month 7, day 5, between the furrow, and the balance, or Libra, first appearance. What is the implication of this astronomical tablet for the chronology of the Neo-Babylonian era? As noted, Saturn has a revolution of 29.5 years, which also means that the planet moves through the whole ecliptic in this period. But for the planet to be seen again at a specific point close to a certain fixed star, for example, of the ecliptic at the same time of the year, we have to wait for 59 solar years, or 2 times 29.5. This interval, actually, is much longer in the Babylonian lunar calendar, as C.B.F. Walker explains. Quote, "A complete cycle of Saturn phenomena in relation to the stars takes 59 years. But when that cycle has to be fitted to the lunar calendar of 29 or 30 days, then identical cycles recur at intervals of rather more than 17 centuries. Thus, there is no difficulty in determining the date of the present text." End quote. In other words, the absolute chronology of Kandalanu's reign is definitely fixed by the Saturn tablet, because the pattern of positions described in the text and fixed to specific dates in the Babylonian lunar calendar is not repeated again in more than 17 centuries. The first 14 years of his reign mentioned in the document are thus fixed to 647 to 34 BCE, as Kandalanu's total reign may chronologically be counted as 22 years, 21 years plus 1 year after Kandalanu. Our tablet establishes the absolute chronology of his reign as 647 to 626 BCE. Like the previous text discussed earlier, BM 32312, the Saturn tablet puts a definite block to the attempts at lengthening the chronology of the Neo-Babylonian period. If 20 years were to be added to this period, the reign of Nabopolassar, the father of Nebuchadnezzar, would have to be moved from 625 to 605 back to 645, 625, and this in turn would mean moving the reign of his predecessor, Kandalanu, from 647 to 26 back to 667, 46 BCE. The astronomical data on the Saturn tablet makes such changes completely impossible. Subheading C. The lunar eclipse tablets. Many of the Babylonian astronomical tablets contain reports of consecutive lunar eclipses, dated to the year, month, and often also the day of the reigning king. About 40 texts of this type, recording several hundreds of lunar eclipses from 747 to about 50 BCE, were cataloged by Abraham J. Sachs in 1955. In about a third of the texts, the eclipses are arranged in 18-year groups, evidently because the Babylonians knew that the pattern of lunar eclipses is repeated in intervals of approximately 18 years and 11 days, or exactly 223 lunar months. This equals to 6,585 and 1/3 days. This cycle was used by the Babylonian astronomers, quote, to predict the dates of possible eclipses by at least the middle of the 6th century BC, and most probably long before that, end quote. As modern scholars call this cycle the Saros cycle, the 18-year texts are often referred to as the Saros cycle texts. Some of these texts recorded series of 18-year intervals extending over several centuries. Most of the lunar eclipse texts were compiled during the Seleucid era, from 312 to 64 BCE. The evidence is that the eclipse records were extracted from astronomical diaries by the Babylonian astronomers who evidently had access to a large number of diaries from earlier centuries. Thus, even if most of the diaries from the earliest centuries are missing, many of their entries on eclipses have been preserved in these excerpts. Many of the eclipse texts were copied by T.G. Pinches and J.N. Strassmeyer in the latter part of the 19th century, and these copies were published by A. Sachs in 1955. Translations of a few of the texts appear in print in 1991. The rest of the texts, translated by H. Hunger, were published in ADT the 5th, year 2001. A preliminary typescript with transliterations and translations of most of the lunar eclipse texts was prepared in 1973 by Professor Peter Huber, but he never brought it into a form ready for publication, although it has been unofficially circulated among scholars for a long time. Huber's memoir has been consulted in the following discussion, but every passage used has been checked and in several cases improved upon or corrected by Professor Hermann Hunger, whose transliterations and translations of these eclipse texts have since been published. The texts recording the earliest lunar eclipses are LBAT 1413 to 1421 in Sachs' catalog. Only the last four of these contain eclipses from the Neo-Babylonian period. But as LBAT 1417 contains eclipses from the reigns of Shamash-shumukin and Kandalanu, the last two Babylonian kings prior to the Neo-Babylonian period, this text too is an important witness to the length of the Neo-Babylonian period. A discussion of four of these texts and their implications for the Neo-Babylonian chronology of the Watchtower Society is presented in the following section. Subheading C1, the Lunar Eclipse Tablet LBAT 1417. LBAT 1417 records four lunar eclipses at 18-year intervals from 686 to 632 BCE. It seems to be a part of the same tablet as the previous two texts in the series, LBAT 1415 and 1416. The first entry records an eclipse from Sennacherib, third year of reign in Babylonia, which may be identified with the eclipse that took place on April 22nd, 686 BCE. Unfortunately, the year number is damaged and only partially legible. The next entry, dated to the accession year of Shamash-shumukin, gives this information. Accession year, Shamash-shumukin, Ayaru, 5 months, which passed by at 40 degrees after sunrise. End quote. At a cursory glance, this report seems to give very little information, but there is more in the few brief lines than one might possibly imagine. The Babylonian astronomers had developed such an abbreviated technical terminology in describing the various celestial phenomena that their reports assumed an almost stenographic character. The Akkadians, phrase translated which passed by, or shadib, for example, was used in connection with a predicted eclipse to indicate that it would not be observable. As Hermann Hunger explains, quote, the eclipse was known to the Babylonians as occurring at a time when the moon could not be observed. It does not show that they looked for an eclipse and were disappointed that it did not occur, end quote. The Babylonians had not only computed this eclipse sometime in advance by means of a known cycle, perhaps the Saros cycle, their computation also showed it would not be observable from the Babylonian horizon. This is also implied in the next line, quote, at 40 degrees after sunrise. 40 degrees is a reference to the movement of the celestial sphere, which due to the rotation of the earth is seen to make a full circle in 24 hours. The Babylonians divided up this period into 360 time units, or degrees, called USH, each of which corresponded to 4 of our minutes. The text, therefore, tells us that the eclipse had been calculated to begin 160 minutes, or 40 USH times 4, after sunrise, which means it would take place in the daytime and thus not be observable in Babylonia. Modern astronomical calculations confirm this. If Shamash-shumukin's first year was 667 to 66 BCE, as is generally held, his accession year was 668 to 67. The eclipse is dated to Ayaru, the second month, which began in April or May. The 5 months indicate the time interval from the previous eclipse. Was there an eclipse of the type described in our text at that time of the year in 668 BCE? Yes, there was. Modern lunar eclipse catalogs show that such an eclipse took place on May the 2nd, 668 BCE on the Julian calendar. It began at about 9:20 local time, which only roughly agrees with the Babylonian computation that it would begin 160 minutes or 2 hours and 40 minutes after sunrise. As sunrise occurred at about 5:20, the error in computation was about 1 hour and 20 minutes. In the chronology of the Watchtower Society, the accession year of Shamash Shemukhin is moved back 20 years to 688 or 87 BCE. No lunar eclipses occurred in April or May that year, but there was a total one on June the 10th, 688 BCE. Contrary to the eclipse record recorded in our text, however, this one was observable in Babylonia. It is therefore an impossible alternative. The next entry in the text is dated to the 18th year of Shamash Shemukhin, that is 650 to 49 BCE. This eclipse, too, was a computed one, predicted to pass by in the second month. It would begin about 4 hours before sunset. According to the modern calculations, that eclipse took place on May the 13th, 650 BCE. The canon of Liu and Fiala shows it began at 1625 and ended at 1819, about half an hour before sunset at the time of the year. According to the chronology of the Watchtower Society, this eclipse occurred 20 years earlier, in 670 BCE. No lunar eclipses took place in April or May that year, but there was a total one on June the 22nd, 670 BCE. However, it did not occur before sunset, as did the one recorded in our text, but early in the forenoon, beginning about 7:30. So again, it does not fit. The next and last entry in LBAT 1417 is dated to the 16th year of Kandalanu. The eclipse recorded was observed in Babylonia, and several important details are given. Quote, year 16 Kandalanu, month Simanu, 5 months, day 15.2 fingers. On the northeast side, covered by. On the north it became bright. The north wind blew. 20 degrees onset, maxima 1 phase, and clearing. Behind Antares, or Scorpio, it was eclipsed. End quote. As indicated by the question marks and the square brackets, the text is somewhat damaged at places, but the information preserved is sufficient for identifying the eclipse. It took place on day 15 of Simanu, the 3rd month, which began in May or June. 2 fingers means it was partial, with only 2/12 of the moon's diameter being eclipsed. The total duration of the eclipse was 20 degrees, that is 80 minutes. If Kandalanu's 16th year began on Nisan 1, 632 BCE, as is generally held, we want to know if there was a lunar eclipse of this type in the 3rd month of that year. Modern calculations show there was. According to the eclipse canon of Liu and Fiala, the eclipse began on May 23, 632 BCE at 23:51 and lasted about 1 hour 7 minutes on May 24th, which means its total duration was about 76 minutes. That is very close to the period given in the text. The same canon gives the magnitude as 0.114. These data are in good agreement with the ancient record. In the chronology of the Watchtower Society, however, this eclipse should be looked for 20 years earlier in May, June, or possibly July of 652 BCE. It is true that there was an eclipse on July the 2nd that year, but in contrast to the partial one recorded in our text, it was total. But as it began about 1500 hours, no phase of it was observable in Babylonia. In summary, LBAT 1417 records 4 lunar eclipses at successive 18-year intervals, 18 years and nearly 11 days, all of which may be easily identified with those of April 21st, 686, May the 2nd of 668, May the 13th of 650, and May 23rd of 632 BCE. The 4 eclipse records are interlaced by the successive Saros cycles into a pattern that fit no other series of years in the 7th century BCE. The last 3 dates are thus established as the absolute dates of the accession year and the 18th year of Shamash Shemukhin and the 16th year of Kandalanu, respectively. The Watchtower Society's attempt to add 20 years to the Neo-Babylonian era and that way moving the reigns of the earlier kings 20 years backward in time, is once again effectively blocked by a Babylonian astronomical tablet, this time by the lunar eclipse text LBAT 1417. Subheading C2, the lunar eclipse tablet LBAT 1419. LBAT 1419 records an uninterrupted series of lunar eclipses at 18-year intervals from 609 to 08 to 447, 46 BCE. The first entries, which evidently recorded eclipses that occurred in September 609 and March 591 BCE, are damaged. Royal names and year numbers are illegible. However, two of the following entries are clearly dated to the reign of Nebuchadnezzar. The words in parentheses are added to elucidate the laconic reports. Quote, 14th year of Nebuchadnezzar, month 6, eclipse which was emitted, literally passed by, at sunrise. And the 32nd year of Nebuchadnezzar, month 6, eclipse which was emitted at 35 degrees, equaling 140 minutes before sunset. The royal name in the original text is written as Kuduri, which is an abbreviation of Nabu-Kuduri-Usur, the transcribed Akkadian form of Nebuchadnezzar. Nebuchadnezzar's 14th and 32nd years are generally dated to 591 to 90 and 573 to 72 BCE, respectively. The two eclipses recorded, one Saros cycle apart, both took place in the 6th month, Elulu, which began in August or September. Both eclipses had been calculated in advance, and the Babylonians knew that none of them would be observable in Babylonia. The first eclipse began at sunrise, the second 140 minutes before sunset. Thus, both of them occurred in the daytime in Babylonia. This is confirmed by modern calculations. The first eclipse occurred on September 15, 591 BCE. It began about 6 o'clock. The second took place in the afternoon on September 25th, 573 BCE. Both eclipses then fit in very well with the chronology established for the reign of Nebuchadnezzar. In the chronology of the Watchtower Society, however, the two eclipses should be sought for 20 years earlier in 611 and 593 BCE. But no eclipses that fit those described in the text occurred in the autumn of any of those years. The next entry, which records the subsequent eclipse in the 18-year cycle, gives the following detailed information. Quote, month 7, the 13th, in 17 degrees on the east side. All of the moon was covered. 28 degrees maximal phase. In 20 degrees it cleared from east to west. Its eclipse was red. Behind the rump of Aries it was eclipsed. During onset, the north wind blew. During clearing, the west wind, at 55 degrees before sunrise. End quote. As stated in the text, this eclipse took place on the 13th day of the 7th month, Teshri 2, which began in September or October. The royal name and the year number, unfortunately, are missing. Yet, as Professor Hunger points out, the eclipse can nevertheless be identified with certainty from the observations given. End quote. The various details about the eclipse, its magnitude or total duration, the total phase lasting 112 minutes, and position behind the rump of Aries clearly identify it with the eclipse that took place in the night of October 6th to 7th, 555 BCE. According to the generally established chronology for the Neo-Babylonian period, this eclipse took place in the first year of Nabonidus, which began on Nisan 1st, 555 BCE. Although the royal name and year number are missing, it is of the utmost importance to notice that the text places this eclipse one Saros cycle after the eclipse in the 32nd year of Nebuchadnezzar. As the last eclipse may be securely dated in 555 BCE, it at once also places Nebuchadnezzar's 32nd year 18 years earlier in 573 BCE. Consequently, all three eclipses in our text concur in establishing 591 and 573 BCE as the absolute dates of Nebuchadnezzar's 14th and 32nd regnal years, respectively. The Saros cycle text LBAT 1419 thus provides yet another independent evidence against 607 BCE as the 18th year of Nebuchadnezzar. If, as is established by the text, his 32nd year was 573-72 BCE and his 14th year was 591 to 90 BCE, Then his first year was 604 to 03, and his 18th year, in which he desolated Jerusalem, was 587-86 BCE. Subheading C3, the Lunar Eclipse Tablet LBAT 1420. Instead of recording eclipses at 18-year intervals, LBAT 1420 contains annual eclipse reports. All eclipses in the text are from the reign of Nebuchadnezzar, dating from his first year, 604 to 03, to at least his 29th year, from 576 to 75 BCE. The first entry, which records 2 eclipses that passed by, that is, though correctly predicted, would not be observable, is damaged and the year number is illegible, but the last part of Nebuchadnezzar's name is preserved. Year 1 of Nebuchadnezzar, month Simanu. The name of the king is not repeated in the subsequent entries, indicating that the king is the same during the whole period. This is also confirmed by the continuous series of increasing year numbers right until the last year preserved in the text, year 29. The entries recording eclipses in the period 603 to 595 BCE are very damaged too, and the year numbers for this period are missing. The first entry in which the year number is preserved records 2 eclipses from the 11th year. Year 11, month Ayaru, 10 USH after sunset, and it was total. Month Arasamnu, which passed by Adaru. The 11th year of Nebuchadnezzar began on Nisan 1st, 594 BCE. Adaru is added to indicate that there was an intercalary month at the end of the year. There is no problem in finding both of these eclipses. Ayaru, the 2nd month, began in April or May, and Arasamnu, the 8th month, began in October or November. The first eclipse occurred on May 23rd, and the second one on November 17th. The eclipse canon of Liu and Fiala confirms that the first eclipse was total and was observable in Babylonia, as stated in the text. It began at 2011 and ended at 2348 on the clock. The second eclipse passed by, it was unobservable, as it occurred in the daytime. According to the canon of Liu and Fiala, it began at 7:08 a.m. and ended at 9:50. Most of the year numbers from the 12th to the 17th years, 593-92 to 588-87 BC, are legible. 13 lunar eclipses are described and dated in this period, 8 of which passed by and 5 were observed. Modern calculations confirm that all these eclipses occurred in the period 593 to 598 BCE. After the 17th year, there is a gap in the record until the 24th year. The entry for that year records 2 eclipses, but the text is damaged and most of it is illegible. From then on, however, year numbers and also most of the text are well preserved. These entries contain annual records of a total of 9 eclipses, 5 observable and 4 that passed by, dating from the 25th to the 29th year, or 580-79 to 576-75 BCE. There are no difficulties in identifying any of these eclipses. They all occurred in the period 580 to 575 BCE. It would be tiresome and useless to expose the reader to a detailed examination of all these reports. The entry for the 25 may suffice as an example. Year 25, month Abu, 1 1/2 Biru after sunset. Month Shabbatu, it occurred in the evening watch. Abu, the 5th Babylonian month, began in July or August. The Babylonians divided our 24-hour day into 12 parts called Beru. 1 Beru, therefore, was 2 hours. The first eclipse is said to have occurred 1 1/2 Beru, that is, 3 hours after sunset. As Nebuchadnezzar's 25th year is dated to 580-79 BCE, this eclipse should be found in July or August of that year, about 3 hours after sunset. The eclipse is not difficult to identify. According to the canon of Liu and Fiala, it was a total eclipse which began on August 14, 580 BCE at 21:58 hours and ended at 1:31 a.m. on August 15. The next eclipse occurred 6 months later in Shabbatu, the 11th month, which began in January or February. It is said to have occurred in the evening watch, the first of the 3 watches of the night. This eclipse too is easy to find. It took place on February the 8th, 579 BCE and lasted from 1808 hours to 2022 hours, according to the canon of Liu and Fiala. In the Chronology of the Watchtower Society, the 25th year of Nebuchadnezzar is dated 20 years earlier. in 600 to 599 BCE, but no lunar eclipses observable in Babylonia occurred in 600 BC. And although there was an eclipse in the night of February 19th to 20th, 599 BCE, it did not occur in the evening watch, as the one reported in our text. Details on some 24 of lunar eclipses dated to specific years and months in the reign of Nebuchadnezzar are preserved on LBAT 1420. Not one of them is found to agree with the Watchtower Society's chronology for the reign of Nebuchadnezzar. Together, these two lunar eclipses form an irregular but very distinct pattern of events scattered over the first 29 years of Nebuchadnezzar's reign. Only on the assumption that his reign began in 604 BCE do we find a far-reaching correspondence between this pattern and the celestial events that gave rise to it. But if Nebuchadnezzar's reign is moved back 1, 2, 5, 10, or 20 years, this correlation between the records and reality immediately dissolves. LBAT 1420 alone, therefore, suffices to disprove completely the idea that the 18th year of Nebuchadnezzar should be dated to 607 BCE. Subheading C4, the Lunar Eclipse Tablet, LBAT 1421. The preserved part of LBAT 1421 records 2 eclipses observed in Babylonia in the 6th and 12th month of year 42, evidently the reign of Nebuchadnezzar. Quote, year 42, month Ululu, day 14. It rose eclipsed and became bright. 6 degrees to become bright, at 35 degrees before sunset. Month Adaru, day 15, 1 and 30 degrees after sunset. 25 degree duration of maximal phase, and 18 degrees it became bright. West wind went, 2 cubits below. Virginis eclipsed. End quote. Provided these eclipses occurred in the 42nd year of Nebuchadnezzar, and there was no other Babylonian king ruling that long in the 6th, 7th, or 8th centuries BCE, they should be looked for in 563 to 62 BCE, and there's no difficulty in identifying them. The first, dated in the 6th month, occurred on September 5th, 563 BCE, and the second one, dated in the 12th month, occurred on March 2nd to 3rd, 562 BCE. The first eclipse rose eclipsed, meaning that it began sometime before sunset, so that when the moon rose at about 1830 at that time of the year, it was already eclipsed. This agrees with the modern calculations, which show that the eclipse began at about 1700 hours and lasted until about 1900 hours. The canon of Liu and Fiala confirms that the second eclipse was total, 1 and 30 degrees or 6 hours after sunset, probably refers to the beginning of the total phase, which began after midnight at 19 hours and lasted until 2:03 a.m., meaning it lasted for about 104 minutes. This is in good agreement with our text, which gives the duration of the maximal phase as 25 USH, that is 100 minutes. In the chronology of the Watchtower Society, Nebuchadnezzar's 42nd year is dated to 583 or 82 BCE, but no eclipses of the type described in our text occurred in that year. A possible alternative to the first one might have been that of October 16, 583 BCE, had it not began too late at 1945, according to Liu and Fiala, to be observed at moonrise, which occurred at about 1730. And as for the second eclipse, there were no eclipses at all that could be observed in Babylonia in 582 BCE. The lunar eclipse texts presented above provide 4 additional independent evidences for the length of the Neo-Babylonian period. The first text, LBAT 1417, records lunar eclipses from the accession year and 18th year of Shamash-Shumukin and the 16th year of Kandalanu, turning these years into absolute dates that effectively block any attempt to add even 1 year to the Neo-Babylonian period, far less 20. The other 3 texts, LBAT 1419, 1420, and 1421, records dozens of lunar eclipses dated to various years within the reign of Nebuchadnezzar, thus time and again turning his reign into an absolute chronology. It is like fastening a painting to a wall with dozens of nails all over it, although but one would suffice. Similarly, it would have sufficed to establish only one of Nebuchadnezzar's regnal years as an absolute date to overthrow the idea that his 18th year began in 607 BCE. Before concluding this section on the lunar eclipse texts, it seems necessary to forestall an anticipated objection to the evidence provided by these texts. as the Babylonian astronomers as early as in the 7th century BCE were able to compute in advance certain astronomical events such as eclipses. Could it be that they also, in the later Seleucid era, were able to retrocalculate lunar eclipses and attach them to the chronology established for the earlier centuries? Could the lunar eclipse texts simply be the results of such a procedure? It is certainly true that the various cycles used by the Babylonians for predicting eclipses just as well could be used for retrocalculating eclipses. And there's a particular small group of tablets showing that Seleucid astronomers did extrapolate such cycles backwards in time. However, the observational texts record a number of phenomena that were impossible for the Babylonians to predict or retrocalculate. Of the records in the diaries and planetary texts, Professor N.M. Swerdlow points out that although the distances of planets from normal stars could be predicted, conjunctions of planets with the moon and other planets with their distances could neither be calculated by the ephemerides nor predicted by periodicities. With respect to lunar eclipses, the Babylonians could predict and retrocalculate their occurrences, but none of the Babylonian methods could have allowed them to calculate circumstances, such as the description of the eclipse shadow and the visibility of planets during the eclipse. End quote. Thus, although the Babylonians were able to calculate certain astronomical phenomena, the observational texts record a number of details connected with the observations that they were unable to predict or retrocalculate. This disproves conclusively the idea proposed by some that the data may have been calculated backwards from a later period. Subheading: Summary and Conclusion. In the previous chapter, the length of the Neo-Babylonian era was firmly established by 7 different lines of evidence. All of them were based upon ancient Babylonian cuneiform texts such as chronicles, kings' lists, royal inscriptions, and tens of thousands of economic, administrative, and legal documents from the Neo-Babylonian period. In this chapter, another 7 independent evidences have been presented. All of these are based on ancient Babylonian astronomical texts, which provide a whole string of absolute dates from the 6th and 7th centuries BCE. These tablets establish, over and over again, the absolute chronology of the Neo-Babylonian era. In summary, subheading 1, the astronomical diary VAT 4956. The diary VAT 4956 contains about 30 completely verified observed astronomical positions for Nebuchadnezzar's 37th regnal year. Such a combination of astronomical positions is not duplicated again in thousands of years. Consequently, there is only one year which fits this situation, 568 to 67 BCE. If this was Nebuchadnezzar's 37th regnal year, as is twice stated on this tablet, then 587-86 BCE must have been his 18th year, in which he desolated Jerusalem. Subheading 2, the astronomical diary BM 32312. BM 32312 is the oldest preserved astronomical diary. It records astronomical observations that enable scholars to date this tablet to 652-51 BCE. A historical remark in the text, repeated in the Babylonian Chronicle BM 86379, or the Akitu Chronicle, shows this to have been the 16th year of Shamash Shumukin. The diary then fixes his 20-year reign to 667 to 648 BCE. His successor Kandalanu's 22-year reign, 647 to 626. Nabopolassar's 21-year reign, 625 to 605, and Nebuchadnezzar's 43-year reign, 604 to 562 BCE. This again sets Nebuchadnezzar's 18th year and the destruction of Jerusalem at 587 to 86 BCE. Subheading 3, the Saturn tablet BM 76738 and 76813. The Saturn tablet records a successive series of positions of the planet Saturn at its first and last appearances, dated to the first 14 years of Kandalanu. Such a pattern of positions, fixed to specific dates in the Babylonian lunar calendar, is not repeated again in more than 17 centuries. This text then again fixes Kandalanu's 22-year reign to 647 to 26 BCE, Nabopolassar's 21-year reign, 625 to 605, and Nebuchadnezzar's reign, 604 to 562 BCE. Subheading 4, the Lunar Eclipse Tablet LBAT 1417. LBAT 1417 records 4 lunar eclipses, each succeeding the other at intervals of 18 years and nearly 11 days, an eclipse period known as the Saros cycle. The eclipses are dated to the 3rd year of Sennacherib's reign in Babylonia, to the accession year and the 18th year of Shamash-shum-ukin, and to the 16th year of Kandalanu, respectively. The 4 interrelated eclipses may be clearly identified with a series of eclipses that occurred in 686, 668, 650, and 632 BCE. This tablet, therefore, once again fixes the absolute chronology for the reigns of Shamash-shum-ukin and Kandalanu, and also indirectly for the reigns of Nabopolassar and Nebuchadnezzar. Subheading 5, the Lunar Eclipse Tablet, LBAT 1419. LBAT 1419 contains reports of an uninterrupted series of lunar eclipses at 18-year intervals directly from the Neo-Babylonian era itself. 2 of the eclipses are dated to the 14th and 32nd year of Nebuchadnezzar. They may be identified with eclipses that occurred in 591 and 573 BCE, respectively, confirming again at these points the chronology established for the reign of this king. Although the royal name and year number are missing in the report on the next eclipse in the 18-year series, the very detailed information makes it easy to identify it with the eclipse that occurred on October 6th to 7th, 555 BCE. This date therefore confirms and adds further strength to the 2 earlier dates in the 18-year series, 573 and 591 BCE. As these years correspond to Nebuchadnezzar's 32nd and 14th years respectively, his 18th year is, of course, once again fixed to 587-86 BCE by this tablet. Subheading 6, the Lunar Eclipse Tablet, LBAT 1420. LBAT 1420 gives an annual record of lunar eclipses from the 1st to the 29th years of Nebuchadnezzar, except for a gap between his 18th and 23rd years. The entries in which regnal year numbers are preserved, about a dozen, give details on some 2 dozens of eclipses, all of which are found exactly in the BCE years that has been established earlier for the regnal years mentioned in the text. As this specific compound of dated lunar eclipses does not tally with any corresponding series of eclipses that occurred in the immediate preceding decades, this tablet alone suffices to establish the absolute chronology of Nebuchadnezzar's reign. Subheading 7, the Lunar Eclipse Tablet, LBAT 1421. LBAT 1421 records 2 eclipses dated in the 6th and 12th months of year 42, evidently of Nebuchadnezzar, generally dated to 563 to 62 BCE. And both eclipses are also actually found in these months of that year, but no eclipses of the type recorded in the text occurred in 583 to 82 BCE, the date of Nebuchadnezzar's 42nd year in the chronology of the Watchtower Society. This tablet therefore provides an additional proof of the falsity of that chronology. And numbers 8 through 11, another 4 astronomical tablets. The 7 astronomical texts discussed above provide more than enough evidence against the Watchtower Society's 607 BCE date, and yet this is not all. Another 4 texts have recently been published that will be described only briefly here. Translations of 3 of these are published in Hunger, ADT the 5th, published in 2001. The first is LBAT 1415, which, as mentioned on page 174 above, is part of the same tablet as LBAT 1417. It records lunar eclipses dated to year 1 of Bel-Ibni from 702 BCE, year 5 evidently of Sennacherib, 684 BCE, and year 2 evidently of Shamash-shum-ukin in 666 BCE. The second is lunar eclipse text number 5 in Hunger, ADT version 5. It is badly damaged and the royal name is missing, but some historical remarks in the text shows it is from the reign of Nabopolassar. One of the eclipses described is dated to year 16 and may be identified with the eclipse of September 15th, 610 BCE. The third is text number 52 in Hunger, ADT version 5. This is a planetary text containing over a dozen legible records of the positions of Saturn, Mars, and Mercury, dated to years 14, 17, and 19 of Shamash-shum-ukin, years 1, 12, and 16 of Kandalanu, and years 7, 12, and 13 of Nabopolassar. Like some of the previous texts discussed above, these 3 texts effectively prevent all attempts at lengthening the chronology of the Neo-Babylonian period. The fourth is a planetary tablet, SBTU, the fourth, 171, which records first and last appearances and stationary points of Saturn in years 28, 29, 30, and 31 of an unknown king. However, as Professor Hermann Hunger has demonstrated, the year numbers combined with the position of Saturn in the constellation of Pabilsag, which is roughly Sagittarius, exclude all alternatives in the first millennium BCE, except years 28 to 31 of Nebuchadnezzar, fixing these to 577-76 to 574-73 BCE. Again, this establishes his 18th year as 587 to 86 BCE. As has been clearly seen, the Watchtower Society's interpretation of the Gentile times requires that these have a starting date of 607 BCE, their claimed date for the fall of Jerusalem. Since that event took place in Nebuchadnezzar's 18th year, that regnal year must also be dated as of 607 BCE. This creates a gap of 20 years when compared with all existing ancient historical records, since these place the start of Nebuchadnezzar's 18th year in 587 BCE. How can this 20-year gap possibly be explained? In this chapter, it has been demonstrated that the 10 astronomical texts presented establish the absolute chronology of the Neo-Babylonian period at a number of points, especially within the 43-year reign of Nebuchadnezzar. Their combined witness proves beyond all reasonable doubt that his reign cannot be moved backwards in time, even 1 year, far less 20. Together with the evidence presented in Chapter 3, therefore, we now have 17 different evidences, each of which, in its own way, overthrows the Watchtower Society's dating of Nebuchadnezzar's 18th year to 607 BCE, showing it to have begun 20 years later, that is, in 587 BCE. Indeed, few reigns in ancient history may be dated with such conclusiveness as that of the Neo-Babylonian king Nebuchadnezzar. Suppose for a moment that Berossus' figures for the reigns of the Neo-Babylonian kings contain an error of 20 years, as is required by the chronology of the Watchtower Society. Then the compilers of the royal canon must have made exactly the same mistake, evidently independently of Berossus. It might be argued, though, that both simply repeated an error contained in the sources they used, namely the Neo-Babylonian chronicles. Then the scribes of Nabonidus, too, who possibly used the same sources, would have had to have dropped 20 years from the reign of the same king or kings when they made the inscriptions of the Hilastel and the Adad-Gupi stele. Is it really likely, however, that those scribes who wrote right during the Neo-Babylonian era did not know the lengths of the reigns of the kings under whom they lived, especially since those reigns also functioned as calendar years by which they dated different events? If they really made such a strange mistake, how is it possible that contemporary scribes in Egypt also made the same mistake, dropping the same period of 20 years when making inscriptions on death stela and other documents? Curiously, then, the Babylonian astronomers must also have regularly made similar mistakes when dating the observations recorded in VAT 4956, LBAT 1420, SBTU the 4th 171, and also other tablets from which later astronomers abstracted their Saros cycle eclipse records, unless of course changes were purposefully made by copyists in the Seleucid era, as the Watchtower Society posits. Still more incredible is the idea that scribes and astronomers could remove 20 years from the Neo-Babylonian era several years prior to that era, as is shown by the oldest diary BM 32312, the lunar eclipse tablets LBAT 1415, 1416, 1417, the Saturn tablet BM 76738, 76813, and the planetary tablet ADT 5 number 52. All the 5 of which inexorably block all attempts at lengthening the Neo-Babylonian period. But the most remarkable coincidence is this: tens of thousands of dated economic, administrative, and legal documents have been excavated from the Neo-Babylonian period, covering every year of this period, except, as the Watchtower Society would have it, for a period of 20 years, from which not one tablet has been found. Again, most curiously, according to this logic, that period happens to be exactly the same as that lost through a series of other mistakes by scribes in Babylon and Egypt, and later by copyists and historians. Either there was an international agreement during several centuries to erase this 20-year period from the recorded history of the world, or it never existed. If such an international plot ever took place, it was so successful that of all the tens of thousands of documents unearthed from the Neo-Babylonian era, there is not one, not even a line in any of them, that indicates that such a 20-year period ever existed. We can safely conclude, then, that the Watchtower Society's chronology is unquestionably in error. But if this is the conclusion of our study, how are we to harmonize this fact with the biblical prophecy of the 70 years during which the land of Judah and Jerusalem would lay desolate according to the Watchtower Society? And how are we to view the year 1914, the supposed terminal date for the times of the Gentiles according to the prophetic time scale of the Watchtower Society? Do not world events clearly show that Bible prophecies have been fulfilled since that year? Those questions will be dealt with in the following chapters.